Hi, I'm Temesgen. I'm a senior machine learning platform software engineer at Bloomberg. I first became interested in data science and AI as a chemistry undergraduate. I really enjoyed investigating the data resulting from experiments. And after taking modules in computational chemistry, the idea of simulating a process, gaining insight with just data on a laptop rather than a huge lab and chemicals was really exciting to me. And data science is a way to do that without needing to be in a lab. I also really enjoyed the variety of problems that could be solved. Well, I started to learning to code whilst on a graduate scheme, and I completed data camp and various internal courses. But after a certain point, I really wanted to formalize my training, so I completed a master's in computer science during the evenings and weekends. And I didn't know about it at the time, but this kind of inadvertently became a great way to keep myself occupied during lockdown. And during this time, I became a lot more interested in the software and infrastructure requirements of data science. And as I went further in my career, I often found that the limiting factor in machine learning was kind of making a difference in large organization was offering data science practitioners reliable, safe methods of going through the machine learning lifecycle right up to production. So that's why I shifted my focus towards machine learning platforms. My proudest moment was during the COVID-19 pandemic. I was working on categorizing transactions for business banking clients during the early part of the pandemic. This work was used to prioritize financial assistance for small businesses. What made me proud of that work was how topical and relevant it was for clients. So my team is responsible for simplifying and scaling AI infrastructure at Bloomberg. We develop tools which enhance the productivity of our internal AI practitioners by enabling them to be more efficient and effective at all stages of the AI development lifecycle. Our goal is to allow AI engineers to quickly go from scratch to a maintainable AI application in production. Now, with that in mind, my typical day involves writing and reading engineering proposals, writing and testing software, and listening to and collaborating with software engineers and internal users of our AI infrastructure. The interesting thing about working on internal AI platforms is that your users are often sitting a few meters away from you, and I really enjoy the tight feedback loop, um, which is, yeah, probably my most favorite thing about the role. Challenge is around maximizing hardware utilization and efficiency, especially regarding inference. Now, from a ML platform perspective, another big challenge I've seen is a lack of reproducibility, especially having accurate provenance, accurate lineage of artifacts in a way which is automated rather than relying on individual users to provide accurate metadata. So those are a couple of the big challenges I see. Oh, it's a very hard question to answer. Whilst it's impossible to predict what the next landmark technology will be, I do believe there'll be a continued focus on standardization and platforms. Machine learning is such a dynamic field, but the core development lifecycle of a model is quite consistent by comparison. And it typically involves, feature engineering, model training, model evaluation, deployment, post-deployment model monitoring. So I think, yeah, and a continued focus on standardization and platforms. Well, we're lucky enough to be in a field where a lot can be done with just an internet connection. So I would definitely say focusing on the fundamentals is really important, and also learning by doing. I've always found that really helped me. And I'd say lastly, it's very important to document your output, um, and do so in a way where you're acting like you're writing a note to yourself in 6 months' time. And I say that because I've been in so many situations where I've thought, okay, I've really understood this now. I won't take a note. I'll remember it. And then, a few months later, you come back and you kind of don't really know how you got to understanding it in the first place. So I definitely think taking notes for yourself is really important. I would say the skills which are undervalued are often pragmatism and communication. And the reason I say that is In large organizations, you're normally potentially designing complicated abstractions. And whilst you kind of understand the requirements and understand kind of why you need to do a certain thing, often the limitation becomes your ability to communicate the value to other people who are in different teams, have different priorities and experiences. So I definitely think communicating the value of what you're trying to do and acting in a pragmatic way is definitely undervalued in the field. That's a difficult question. I'd say I'm less focused on individuals and more on projects. And out of all the projects I'm thinking of, the vast majority of them are almost always like formed from the collaboration of many people and many organizations. So it's a real collaboration. I think the one that springs to mind is PyTorch. And the reason I say that is I had the opportunity to attend a conference last year, and the keynote was by one of the co-founders of PyTorch, Sumit Chintala, and he spoke about the importance of accepting community contributions, and that really struck me. One thing I really like about PyTorch is a number of extension libraries for quite niche ML use cases. There's one called like PyTorch Geometric Temporal, which is great at working with graph data over time. And that's kind of one thing I really took away from the talk was him stressing the need for collaboration and accepting community contribution. And it, yeah, really took home the message of the fact that often the best things that we use are never really, dreamt up by one person, kind of in complete isolation from everyone around us. It's almost always a result of collaboration. I would recommend a podcast. It's also a radio program by the BBC called More or Less. And every week, economist Tim Harford discusses kind of dubious statistical claims made in the media that week. And an example of a particular recent like episode which I enjoyed was they kind of did a deep dive on the claim that the fossil fuel industry attracts $7 trillion per year in subsidies, and they went into the methodology behind that kind of seemingly shocking statistic, and it kind of showed that when even a little bit of scrutiny is applied, it kind of fell down a bit. And what I quite like about the radio program and the podcast is it encourages a healthy amount of skepticism around statistics you hear in the news because it often feels like we're bombarded with numbers, and it's kind of important to have a healthy level of skepticism to understand, if it's an extraordinary claim, then it probably needs a bit more investigation before you can trust it. So yeah, more or less.